Hwk27 question 10. I've amended the diagram that comes in the question to include all the forces and acceleration that need to be included. This gives us a tension on either side of the pulley, pointing towards the pulley, the weights of particles A and B, the reaction force from the table on A, and because we are told that it's a rough horizontal table, we have friction going backwards to the left. In part A, we're asked to find the acceleration of A during the first 2 seconds of movement, up to the point where B hits the floor. This is a Suvat equation. We are given the distance travelled, the starting velocities because the system starts at rest. The acceleration is what we're trying to find. It takes 2 seconds, and we don't know the final velocity of B as it hits the floor. So the equation that I want to use is S equals ut plus half at squared. Substituting in gives us 1 is equal to 0 plus half a times 2 squared, and this gives us a equals 0.5 meters per second squared. In part B, I need to resolve forces to find the coefficient of friction mu between A and the table. If I resolve the forces on A, taking my right as a positive direction, T, take away friction, is equal to mass 3m times the acceleration 0.5. I've got too many unknowns in this equation, so I have to leave it just for the moment. If I resolve vertically on B, then I have the weight going down, 2mg, take away the tension, pulling it back up, is equal to the mass times the acceleration. This equation can be rearranged to find T. T is equal to 2mg, take away m. I can substitute that one back into my first equation. I also want to substitute away for friction. Friction is equal to mu times the reaction force on A, and as there is only one vertical force going down on A, its weight of 3mg. R is equal to 3mg, and I can substitute that in. So if I now substitute both of these into my first equation, I get 2mg, take away m, take away 3 mu mg equal to 3 over 2 lots of m. M appears in every term here, so I can simplify that by dividing through by m. 2g minus 1 minus 3g mu equals 3 over 2. If I rearrange to make mu the subject, I get 3g lots of mu equal to 2g minus 5 over 2. And then if I divide through by 3g, I get mu is equal to 57 over 98, which is 0.581 to 3 significant figures. Mu is a coefficient, so there are no units in this question. Part C is a 2-part Suvat question to determine whether A reaches the pulley. We need to know how fast it was travelling at the point that B hits the ground, because at this point its acceleration is the 0.5 that we found earlier in part A. This is a Suvat problem. I've only got one unknown this time. I've got a choice of 4 equations I can use to find what the velocity is. My preference is v equals u plus at. So v is equal to 0 plus 2 times 0.5. So v is equal to 1 meter per second. That bit's important because this is now my initial velocity at the point after B has hit the ground. At this point it is then slowing down until it reaches a speed of 0. This means I need a new acceleration. Now, in the majority of questions where a pulley problem occurs, where either the string snaps or a particle hits the ground or hits a pulley, the other one is going through the air, and I can use gravity as my acceleration. In this question, I need to find what A is. At this point, tension is no longer pulling my particle. I only have one force occurring, which is the friction from the table. F is still equal to ma. The friction that I found earlier was 3mg for r times mu, which was 57 over 98. And that is equal to my mass, 3m, times my acceleration. So, if I simplify this equation by dividing through by 3m, all I get is g times 5.57 over 98, and that gives me a equals 5.7 meters per second squared. I don't have t in this equation, but I don't need it. So I need to use SUVAT again. This time the equation that I want to use is v squared equals u squared plus 2as. V is equal to 0, u is equal to 1, plus 2 times 5.7 s. There's one change I need to make to that, sorry. The acceleration is negative because it's going backwards, so that's going to make a little bit more sense in this problem. This gives me s is equal to 1 divided by 11.4, which is equal to 0.0877. Now I need to compare this to the remaining 0.3 meters which are left over. This is clearly less than 0.3, and therefore I need to write a conclusion: particle A does not reach the pulley.